So yesterday we explored the function y equals x squared, which is the parent function of all quadratics. And we talked about its properties, right? Which way was it open, or did it open? Y equals x squared. Up, right? So that's your original function, and opened up. What was the vertex? 0, 0, right? And then do you remember the step pattern? 1, 3, 5, right? So you go up 1 over 1, up 3 over 1, and then up 5 over 1. Perfect. Now this is speaking about the original function, which is the parent function y equals x squared. We also explored what happened to the function if it was multiplied by a constant, right? So if I had 2x squared, or if I had 0.5x squared, or if I had the negative. Do you guys remember what happened? So if I have a negative a value, I had a deflection.
And if the value is higher than 1, it's a vertical stretch.
Yep.
And if it is less than 1, it is a compression, vertical.
If it's between 0 and 1, I had a compression, vertical compression. Perfect. So this a value, right, affects the vertical stretch, vertical compression, and the reflection of the graph. Now we're going to explore what happens if instead of multiplying, right, so I'm not multiplying anymore, but what if I add a value to the x squared, okay? Or what if I subtract a value to the x squared? That's the first thing we're going to look at, okay? And then we're going to discuss what do we call this kind of transformation, all right? So what I want you guys to go to, I want you to go to Desmos. We're going to, first thing that we're going to graph y equals x squared. Okay, because we compare everything to the parent function y equals x squared. So my second function that I want to graph was y equals, can you guys help me because I don't have the notes, y equals x squared, was it plus 2? Plus 2. So I have y equals x squared plus 2. What happened to that graph? The vertex changed. What's the vertex now?
2. Y is equal to
0, 2. A vertex is a point, right? And the point has x value and a y value. So this point right here, right, is, I don't know if you guys can see this, is 0, 2. Okay, so the x value is 0, the y value is 2. So what value changed? The y value has changed. So basically what happened is the original graph, which is the y equals x squared, the red graph, has been lifted up 2 units, right? So it went up 2 levels. We can look at every point, right? So even if I look at this point right here for the original one, which is 1, 1. Where is it? 1, 1, sorry. This point right here, which is 1, 1. Okay. If I look at 1, it became 1, 3. So on the blue graph, it became 1, 3. You can't. I'm trying. Okay, so it became 1, 3. So also what happened is the x value stayed the same, which is 1, but the y value went up 2, from 1, 1 to 1, 3. Okay, what was the next? You guys are looking at the homework booklet. This is not the right booklet. Okay, how about this one? What do you see?
The vertex changed again, but instead of it was 0, 2, it's 0, 4.
So compared to the red one always, right? Now my vertex is 0, 4. Okay? Do you guys have can you tell me what's happening here?
The k value is motivating to change my value.
The y value. Okay, so it's bringing it up. Which way? Do we call that horizontal or vertical? Vertical. So what we call this transformation, we call it a vertical translation. Okay? So this is called a vertical translation. Can you give me the next equation? So y equals x squared minus 1. Okay? So what happened here? It went down 1. So that's a vertical translation, 1 unit down. Okay? So that value that you see right here is causing, a vertical translation either up or down. Okay? It's affecting your vertex. Okay? So let's look at filling out the table. So what's the value of k for the first one? K is 2. Okay? Remember that. It's y equals x squared plus k. K is outside the x squared, so it's added to the x squared. So in this case, k is equal to 2. Which direction was your graph open? Up. What was your vertex? 0, 0, 2, right? So if you look at this one, which is the blue one, my vertex is right here, which is at 0, 2. Okay? So my vertex is at 0, 2. What's the axis of symmetry? Did it change? What do I write? X equals 0. And then what can you tell me about, compare the shape of it to the shape of the original one? What do we say?
Higher to low.
We say so the terminology that we're going to use vertical translation two units up. You'll see that I will use VT for vertical translation. Okay? So, how about the next graph? What do we say? K value is 4. Direction of opening. The vertex is 4, 0, 4. And axis of symmetry. And vertical translation 4 units up. Y equals x squared minus 1. What is my k value? Negative 1, so that's your k value. Direction of opening? Direction of opening. Look at the purple. Up. The only thing that's going to affect your direction of opening if it's multiplied by a negative outside the x squared. So if I had y equals negative x squared, that's the only time you're going to have a reflection. Okay? If your k value is negative, it's not going to affect your direction of opening. Okay? So, it's opening up. My vertex is
0,
and my axis of symmetry is, and it's a vertical translation, 1 unit down. Okay? So you took your graph and then you shifted it down 1. What can you tell me about, without me graphing it, what can you tell me about y equals x squared minus 3? So what's your k value? Yep. Which way is it going to open? What would be your vertex? Axis of symmetry. Vertical translation. Perfect. So that K value is the Y value of your vertex. Okay? So that being said, the K value here is going to be the Y, excuse me, value excuse me, of the vertex.
So over there on y, you need y-axis, right? Because it's confusing when you were saying y equals x squared plus k, and then you were saying y value.
That K value is the Y value of the vertex. You see how the K value here, right, is the Y value of the vertex. Right? They match. You guys agree with that? So it is the optimal value. That's correct. So how does the K value of K affect the basic parabola? When K is greater than 0, the parabola shifts up. When K is less than 0, the parabola shifts down. It still opens up, but it shifts down. Like you're in an elevator, right? And you're going down. The value of K describes the, yes, we're going to say that next. So we're going to say for now, we're going to say the value of K describes the vertical translation, which is, it is known as the Y value of the parabola of the vertex, or optimal value. Okay, so it's a vertical translation, either up or down, which is going to affect the Y value of the vertex, and in turns, the Y value of the vertex is known as your optimal value. Are we okay with this? Does it change your step pattern? No. Right? If I go back to my original, to my graph, right here, anyone, okay, take whatever, right? This is 3. Okay. So from the vertex, I go up 1 over 1. Then I go up 1, 2, 3 over 1. Yes? Then I go up 5. I don't know if I can see this. 1, 2, 3, 4. Probably if I bring this down somehow, I can see it over 1. So you see that my step pattern didn't change. It was still 1, 3, 5, right? My step pattern did not change. What changed is my starting point, which is my vertex. My vertex is now at 0, 2, and not at 0, 0. Do you guys understand that? So, here's what we're going to do. So, you have this equation. So for each of the following, state the transformation and graph the parabola. Okay? So the equation is y equals x squared plus 3. What kind of transformation do I have?
Stretch, vertical stretch.
Where do you see the stretch?
translation.
Vertical translation. I have x squared plus 3. That 3 is the k value, yes? That 3 is like this. Do you guys see the similarity between the two? Except instead of k, I have a 3. Yes? So we call this a vertical translation. 3 units. Why can't I call it y? Because I have a y here. It's the y value of the vertex. Okay? It is not the y. The y is a variable in your equation. So you see how you have a y here? If you have another y here, then they cancel each other. We can't do that. So, do we understand how I named the transformation? It's a vertical translation 3 units up. Now, can you tell me what your vertex is? 0, 3. So vertex is 0, 3, because we know that this is the y value of the vertex. What would be my step pattern? 1, 3, 5. It's not going to change. This is not part of your transformation. This is for me to be able to graph, okay? So step pattern is 1, 3, 5. So let's try to graph this. My vertex is at 0, 3. So I have to locate my vertex first. So that's 1, 2, 3. So that's where my vertex is. To find my next point, what do I do? Up 1 to the side 1. So if I go up 1 to the side 1, I'm going to end up right here and right here. Remember, I go to both ways. Okay? And then from this point, where do I go?
3.
Up 3. So 1, 2, 3 over 1. Same with this. I go up 1, 2, 3 over 1. If I have room, I would have went up 5 over 1. Okay? But I don't have room, so my graph is going to look like this. I want to see values on the x and y axis. If I don't see values, I'm going to remove. Let's say if the graph is worth 2 marks, you'll get only 1. If I don't see values, if I don't see numbers, some numbers, it doesn't have to be all, but I have to see at least the vertex and then some other numbers. Otherwise, you will lose marks. So what I want you guys to do is I want you to try and draw the next question.